So, hi everybody. My name is Trick, and so as you can see, my study is on the regulation of IP10 in pregnancy associated with high-risk bacterial infection. And before going to my study, I want to spend some time to say that this internship is a great experience I have been through, which allowed me to have a deeper appreciation for scientific research and its translation into medical application. In our project, we study about, we concern about the health and the welfare of our women and children during pregnancy. And we try to understand the mechanism underlying preterm labor, which is baby delivery earlier than 37 weeks. Recent statistics show that 1 out of 8 babies born in the US suffer from preterm labor. And the total healthcare cost is around 26 billion US dollars every single year. Can you believe it? And one question is that why do we spend so much money and effort to prevent this from happening? The answer may be because we care about our future generation. Each and every single child coming to this world deserves to be born safely and protected. To accomplish this task, our lab priority is to use scientific insight at the molecular scale to develop a new method for the early detection of preterm labor with the hope to prevent infant mortality. Simply put, to save the life of our children. It turned out that there are 4 main causes that can lead to preterm labor. Across the totality of all the causes, infection and inflammation are the major threat to our developing baby. For decades, we all assume that this microenvironment is completely bacterial-free and sterile in order to protect the baby from potential pathogens such as bacteria and viruses. Wrong. Believe it or not, scientists nowadays prove that there are permanent residents such as bacteria and viruses living within this environment together with our baby. And under the external stimuli, these friendly, happy bacteria and viruses become very angry and may cause infection. And bacterial infection trigger immune response and inflammation. In fact, inflammation is a total killing machine because it's responsible for 40% of infant mortality every single year. So the question here is that how do these bacteria cause inflammation and lead to preterm labor? In this study, we look at a specific protein called interferon gamma inducible protein 10 kilodalton, or IP10 for short. This protein is responsible for embryonic implantation as well as the formation of fetal maternal circulation. However, this protein is also famous for being involved in the pathogenesis of a series of diseases, including cardiovascular diseases, in which IP10 is found in the endothelial tissue of our blood vessel and induce T-cell migration into our blood vessel and cause vascular rupture. Also, in multiple sclerosis, IP10 induces the migration of T-cell to our central nervous system and damage the myelin cover of neuron cell and inhibit nerve signaling. In the same manner, IP10 induces T-cell migration to the beta cell of our pancreas and destroy the newly formed insulin and lead to type 1 diabetes. IP10 ability to attract CD8 T-cell is also relevant in the context of pregnancy. IP10 induced inflammation can also cause preeclampsia as well as hypertensive pregnancy complication. To sum up, this protein is a potent inflammatory marker in multiple diseases. It is found in the granulocyte and the endothelial cells. It is easily induced by interferon gamma, and it has a special, unique ability to attract CD8 T cell as well as other pro-inflammatory cytokines. For the purposes of this study, we look at the secretion of IP10 at the specific region of the uterus, namely the decidua. Why do we choose the decidua? Because it is the important interface between the mother and her child. And it is also well known as one of the immune regulators during pregnancy. Well, let's begin with my objective. So in this follow-up study, we try to understand the regulation of IP10 gene expression during bacterial infection in pregnancy. And under normal condition of pregnancy, IP10 is silent and not expressed in the decidua. And without the expression of this protein, a quiet condition of the uterus is guaranteed. It's guaranteed. Using immunoprecipitation, my mentor, Dr. Silasi, as well as Dr. Young, have identified a specific population of histone, namely the trimethylhistone 3 localized at the promoter of IP10 gene. And technically speaking, in this method, we use formaldehyde 1% to cross-link the histone 3 and the DNA together. Then this complex is broken down into smaller pieces using sonication. Then we allow the antibody to bind to the trimethylhistone 3 and allow precipitation to occur. In the final step, we collect DNA fragment, amplify it with previously designed primer, and run a DNA gel. And detection of DNA sequence where trimethylhistone 3 bind to allow us to strongly conclude that trimethylhistone 3 is being recruited to the promoter of IP10 DNA during normal pregnancy. To summarize, based on those data, we rationalize that the decidual use trimethylhistone 3 as a chromatin marker to control the expression of IP10 gene during pregnancy. So now it's come to my hypothesis. In the presence of microbial products such as LPS, an unknown mechanism triggers the demethylation of trimethylhistone 3 and initiate IP10 gene expression, which may eventually lead to preterm labor. For this ex vivo study, we got our decidual sample directly from the placenta of 4 healthy term labor C-section patients at Yale New Haven Hospital. We then used 4 main methods, including qPCR, Luminex, Western blotting, and chromatin IP, to investigate the expression of trimethylhistone 3 as well as IP10 during bacterial infection induced by LPS. The first question is, does LPS really increase IP10 expression in the decidua? Using qPCR, we observe a significant increase of IP10 expression in the presence of LPS. Also, when using Luminex, to examine the cytokine level of IP10, we also observe a significant upregulation of circulating IP10 level. Conclusion: LPS induces the expression of IP10 in the decidua as well as the circulating level of IP10. That brings us to the second question. Does LPS infection change the protein expression of trimethylhistone 3 and histone 3? To test our hypothesis that only the trimethyl version of the histone 3 can regulate IP10 gene expression, we then perform Western blotting and investigate the protein expression of total histone 3 and trimethylhistone 3 for the normal decidual cells and for LPS-infected decidual cells. And the protein expression of these 2 histones are then normalized to the protein expression of beta-actin within the same length. And in the end, these Western blot data reveal very, very little change in the protein expression of total histone 3. However, we observe significant downregulation of protein expression for trimethylhistone 3 in the presence of LPS. Conclusion: we observe significant downregulation in the expression of trimethyl histone 3, and this is good. For the final pieces of our data, we then perform chromatin IP and qPCR again to investigate the expression at RNA level of trimethyl histone 3 during bacterial infection. And from this data, we observed a significant decrease in the population of trimethyl histone 3 during bacterial infection. Taken all together, we now confirm that the demethylation of trimethyl histone 3 release the IP10 DNA from epigenetic suppression and initiate IP10 gene expression and lead to preterm labor, maybe. To take this project to a higher level, I then propose a bigger picture which clearly allow us to clearly visualize what is really happening during bacterial infection in pregnancy. Under normal condition of pregnancy, a potential complex called PRC2 or polycomb repressive complex 2 can catalyze the methylation of the normal histone 3 and suppress the expression of IP10. And the activation of this enzyme may depend on the presence of menstrual-related hormones such as estrogen and progesterone. During bacterial invasion, our maternal-fetal interface is continuously exposed to microbial products such as LPS, which then strongly induce the first line of defense, macrophages, and a series of pro-inflammatory cytokines to the site of pregnancy. An enzyme localized specifically on this macrophage called JMJD3 may catalyze the demethylation of trimethyl histone 3 at lysine 27. And that leads to gene expression of IP10. Activated IP10 then attract foreign CD8 T cell as well as other pro-inflammatory Th1 cytokines such as interferon gamma and TNF alpha to the site of pregnancy. And now everything is getting sexy. The illegal immigrant CD8 T cell then turn really crazy, target, damage, attack both the baby and her mother, his mother, I don't know. And the presence of extra interferon gamma then induce even more synthesis of IP10 and create a complete circle of positive amplification. And this type of infiltration for a long time will cause extensive inflammation, and the consequences are pregnancy complication, neonatal impairment, cerebral injury, preterm delivery, and infant mortality. When you think about it, this is stupid. How can our body synthesize something that can seriously devastate itself? Well, get used to it. This is how our immune system works. At the end of the day, our data support an obvious correlation between the demethylation of trimethyl histone 3 and the expression of IP10. And I believe that this may be the ticket for future early detection and prevention of preterm delivery, as well as other bacterial-induced inflammation in general. Finally, I want to thank my research mentor, Dr. Silasi, and my lab PI, Dr. Gilmore, as well as other lab members for always supporting me and giving me a chance to stand here and present my project. Thank you, everybody.
Any questions? No?
Do you have any idea maybe how LPS will act in the membrane, maybe affecting the methylation which is happening in the nucleus?
Inside the nucleus?
Yeah, so you're going from something from outside to the
Yeah,
nucleus.
from outside.
Any idea, potential? Do you have any idea?
I don't know if LPS will attack the nucleus or not because it cannot enter the cell. So I think maybe viruses can do it. And it will be on another pages of that study.
Okay.
In this project.
Very good. Any question?
Good job.
Very good.